Hello, my name is Mark Pimentel. I'm a CAM application specialist here at Hawkridge Systems, and in this video, I'll show you how you can design your own soft jaws. So we'll start with a blank that I got from my supplier, and I'm going to turn this single blank into an assembly and then design my soft jaws in that assembly. So we'll start by going up to File, Make Assembly from Part, and all this is going to do is just open up a new SolidWorks assembly where that blank becomes the first component. And as the first component, it will be fixed in the model space. Now, it's asking me where I'd like to put that component. I'm just going to go to the top right corner and click the green check mark. Basically, that will line up the origin of my part with the origin of this assembly. And if you take a look in the left menu, there's a little F next to the component indicating that it's fixed in space. So I actually can't move it now. This becomes the anchor for the rest of the assembly. The assembly I want to make is essentially just 3 of these parts. This is a 3-jaw chuck. I need 3 of these. Rather than importing the other 2, I'm just going to make a copy of the existing one because it's literally the same part file, so there's no need to do any extra work there. But by doing it this way, I'm actually linking it back to the original SolidWorks model as well. So when I make a change to one of these, it'll carry through to all 3 of these. So in an assembly, what we want to do is to add relationships between these 3 parts, and since this is going to go on a chuck face and I need these to be at angles to each other, I'm just going to add some mates to this, and mates are those relationships inside of assemblies. So the first mate is all 3 of these are going to sit on a back face, so I'm going to click on the back face of the anchor, the back face of that part there, so that lines those guys up there so that they are coincident. I'll do the same with the anchor and the second part, and you can see that that shifts it in place so that they again become coincident. And now I need to add a little more in terms of relationships here. I need these to be at angles to each other, and this part in particular has these mating faces here. So I'm just going to use these faces to start to get these guys to be in plane with each other. So I'm going to make it simple on myself. I'm just going to make them parallel to start, because I'm pretty sure that these are coincident. I'm pretty sure these guys line up, but I just want to make sure that I don't disrupt the other mates that I have to make. So I'm going to start by making them parallel. And if you see a situation like this, it just means that these are parallel, these faces are parallel, but they're not in the same direction. So I'll just go over to the left menu and I'll just tell them that they're in the opposite direction. So simple enough, I can still move that guy. It's just constrained by the 2 faces that I've given it so far. I'll do the same with the other part. So I'll click on this face here, make sure I click on parallel, and I'll click on this face as well. And those are in the same direction. I'll again go to the left menu and just make sure that they're in the opposite direction. So now those 2 components are mated to the anchor, and that just makes them stay parallel to each other like that. Now I could do the same with the other one, but the other constraints I'm going to add to this, the other mates I'm adding to this assembly, should lock that all in place. And I don't really need to worry about making this one parallel with the other one, because just the shape of these parts will make them parallel anyway. Just the main geometry of how this whole thing is working here. So the last little bit here is these are all going to sit on the chuck face, and they're all going to be basically concentric. When these jaws close, they'll be concentric. So I'll go over to the left menu. I'll click on concentric, and again I'll start with the anchor, and then I'll go to the other component here. And because I told it I want it to be concentric, but those other 2 faces need to be parallel or coincident, that lines it up right there. And if I just jump out of the mate menu here for a second, we can see that if I try and grab this component, it doesn't move. And it tells me that that selected component is fully defined. Basically, by giving it those 3 mates, it is locked in space there. And that's basically how we're going to build the rest of this assembly. I'm just going to go to the final component, and I'll click on that face there, make sure I choose concentric, and then I'll choose the face of my anchor, and now those all line up, and that is fully constrained. So now I have a SolidWorks assembly that I can now create my soft jaws off of. So I need the part that I'm actually going to hold in this thing to define the actual shape of that soft jaw. So I'll go up to the top left corner, click on Insert Components, and I'll browse to the actual component that I'm looking to use, that I'm going to hold in this soft jaw. So that'll just be that component there. Okay, And just like every other component, it's just going to ask where I want to put it. This time, I'm just going to click anywhere away from the main assembly, and I'm going to mate that to my actual assembly here as well. So we'll start by going back to the mate menu. Okay, and obviously this being a turned part, this will also be concentric with the assembly. So I'll grab any cylindrical face on my part. I'll click on the cylindrical face of my anchor. And likewise, that's in the wrong direction. So I'll actually make them in the same direction by clicking on that icon right there. And then that gives me a concentric mate. Now I can pull this back only because the only limit I have on this is to remain concentric. And the fact that this part is revolved, I don't really need to lock it in space, but if you are making soft jaws for any kind of irregularly shaped part, not a revolved part, then you might want to try and give it some parallelism as well. So I'm going to go parallel, and then what I can do is I can go to my SolidWorks feature tree, go to this part that I'm trying to design here, and I'll just grab maybe one of the planes. I'll go to my anchor, and find a plane that I'd like to be parallel to as well. So maybe the top plane of that anchor. So again, it's a revolved part. It doesn't really change the shape of the part however I'm holding it, but if this was some sort of irregularly shaped part, maybe I'm holding some square stock or some hexagon stock, I might want to line up my soft jaws just right to get the exact shape. Okay, so the only thing left to do is tell it how much we want to hold on this thing, and that might just be eyeballing it. I can just kind of draw it in there just by clicking and dragging, or if I know specifically from one face to the other how I'd like to hold this, I can use one of the other mates in here that is a distance mate. So in this case we're working in metric, so I'm going to just click on this face here and this face here, and you can see that it's actually placing that distance between them. Now we can't really see it because it's only 1 millimeter. I'm going to set this to 50 millimeters just so we have something to see on screen here. So by seeing that distance there, I probably want to hold it a little bit more than that. So I'm going to just flip the dimension, and now I'm holding it by 50 millimeters. If I can't really see what's going on there, you can see a little bit of a highlight there, but if we really wanted to, we can make these parts transparent. So what we can do is exit out of the mate, and I'll go back to my anchor here, and let me just right click on it, and I'll just change transparency. And then that way I can kind of see how much we're holding on to this thing. So now that gives me the ability to at least eyeball how much I'm holding on. I'll go back to my mates menu, or at least the list of mates that I have, and now I can edit that mate just like any other SolidWorks feature. The mate happens to just be any type of, like any other feature inside SolidWorks. I can now go in there and make a modification. So I'm just going to kind of eyeball this a little bit by just clicking on the arrows. And let's move this in maybe just a little bit more. I want to get more of that cylinder. And that's it right there. So let me just pull that back a little bit. Okay, so we're going to hold it by 90 millimeters. Okay, and I'll leave that transparent so that we can see the effect that the solid takes on the part. But all of this together shows how we might want to hold on to it, but we still need to actually design or make the design of the soft jaws. So how to do that is basically with all the components on screen, I now will go back to my anchor here, because again, this is the one of 3 parts, but we'll use this one as the driving force here. And I'll just go into Edit Part. So in this case, I haven't given it this assembly a name, so I'm just going to save this somewhere. In this case, I'll just save it to my desktop here. Inside the assembly, if you open up the part for editing, what we're actually doing is somewhat opening that same SOLIDWORKS part file behind the scenes. We're still looking at the assembly, but we have access to the original SOLIDWORKS part here, and now I can do a few things to modify the part. So if I added sketches or did any kind of solid modeling on this thing, it would go back and affect all 3 parts. It would go back and save to the original SOLIDWORKS model. What I'm looking to do here is I'm actually going to go into Insert, Features, and I'm going to use the option called Cavity. And what this allows me to do is choose another design component, another component on the screen, so in this case the part that I'm looking to machine here, and I'll use that to actually cuts in the or almost like we would do with extrusion cuts, I'm going to remove that interface between the two components. So if I rotate that around, now you can see that this component now has that cutout in it. I'll exit out of the modification of the component. I will now hide the part we're looking to machine, bring back, remove the transparency, make it opaque, and you can see now I've designed my soft jaws. And because I did it to the one component of 3, but I saved all that back to the original component, each one of these now has that same shape. So now I have soft jaws that I can use on my design assembly there. And I can use this in my CamWorks to define my soft jaws. The only thing you want to keep track of is which coordinate system you save this under. So in this case, I'm using the original SolidWorks coordinate system, but when I bring this into CamWorks, I might want to line this up exactly with the way that I have it, the way I have things situated inside of CamWorks. Especially if this is not a nice round piece of stock, maybe we're designing soft jaws for some sort of irregularly shaped part. I'm going to want to create a coordinate system on here that when I actually do import this into CamWorks, it lines up the way I like. So to do that, we're just going to go back to our anchor here. I will make a sketch on the back face, and it's just really simple. We're just going to draw a couple of lines here that we can use for defining a coordinate system. So just 2 lines. Now that we have 2 lines in space, we'll go up to Reference Geometry, Coordinate System. It's going to ask us for the origin of our new coordinate system. That'll be just that first point that I drew there. This is going to go on a lathe, so I want to make sure that my x-axis is pointing in that direction, and my y-axis is pointing in that direction there. So I just click on that line, and then I get that. Now that gives me a coordinate system that I can work with. If that is not the proper z direction for how I'm going to set this up on the machine, if I put this on the main, it looks like it'll look good that way. If I put this on the sub, depending on how my coordinate system on my sub spindle is defined, I might want to flip that. But that's something we can do inside of CamWorks. So on the design side, this is all I really need to do to define a soft jaw, to design it and define it for use in CamWorks. If you like what you see here, we actually have a learning path on our partner company's website, SolidProfessor. Inside SolidProfessor, you'll find many different learning paths or courses you can take to help you get up to speed with both SolidWorks and CamWorks. And one of those learning paths is CAD to CAM, or it's a course designed for CAM users of any software that are learning on how to use the CAD functionalities in their embedded software, in their integrated software. So in this case, SolidWorks capabilities that help you on the programming side. So if you're interested in this, take a look at the link provided in the description of this video, and you can see more on what SolidProfessor can provide for you, and you can also see more videos on how to program inside CamWorks. Thanks for watching.